Hello guys, this is another tutorial from Codeworks. In this tutorial I am going to discuss um, Dequeue or double-ended queue. Let's save this file first. Um, Dequeue, Dequeue file before? No file at all. Dequeue.c. Let's increase the size of it. Now let's include the main function stdio.h. Then I don't need any other function like that. Okay, let's define the data structure. struct struct node int data, then struct node next pointer struct node next. Okay, then type def type def struct node only node. Now I need not write struct node every time. I can just write node and that will do the trick. Okay, type def struct node. Okay, now I need to I need two variables now, front and rear. Node star front comma star rear. Initially both are null. Now void add, this would take an argument, the data part, add data. Now node say ptr, this is some temporary node. No, just like temp. Node temp equal to node star node star malloc size of node. Okay, then let's include another essential file. I need it. It's the stdlib.h hash include stdlib.h. Then okay, this is done. Okay, now data part of temp would be this data. So data part of temp data equal to data. Then next part of temp would be null. Temp next equal to null. Okay, this part of temp is null now. Okay, now the main part. If front equal to null, means if there are no elements, then obviously rear is also null, but I'm going to put an or rear equal to null. In that case front equal to 10 and rear is also equal to 10. This is similar to what we have done in queues. Else what? Else, like if there is a front, okay, like as I discussed earlier, it has two parts: insert at beginning and insert at end. Insert at an end is pretty obvious, is normal queue. Just to insert at beginning, add at b e g at beginning. Else what else? Add at beginning. Add at beginning means add in front of add at front. Okay, then what I will do is I have to initialize the next of front. Let the next of front point to temporary data means 10 and let's update front. Now front equal to 10. Front next equal to 10. Now front equal to 10. What this does is the next pointer of front points to temp. Now front is a temp, so this adds temp in front of the queue. Okay, this is 10. Okay, added beginning is done. Almost same thing with added temp. You just copy it. I don't keep typing it again. What have we done? Control end of the file, then print it. Added end. Added beginning, added end. Okay. Now added end means added rear. So this is what actually happens. Okay. Now what this I have to do is I have to initialize the next of temp, the next of temp, the next of temp would be my rear, and rear would be temp. As simple as that. This is like normal queues. Now delete at um, rear, void delete at rear. I'm doing void, but you can do anything you want. Doesn't matter. You can even return the value. Delete at rear. Now if rear is equal to null, rear is equal to null, then print a message, um, no elements found, printed queue empty, or no elements found, whatever, queue um, empty. Okay, if here is not null, means if here has some elements, let's say one element, sorry, not rear has elements, the queue has some elements, then to delete it, what I have to do is just increment the value of rear to the next position, like rear is equal to the next pointer of rear. Rear is equal to the next pointer of rear. Okay, so this is my new rear now. Just increment the value of rear, and the initial element is deleted. This also serves another purpose, like it solves another problem as well. Like the rear is um, if the rear is the only element, then next of rear would mean it is null. So it automatically initializes it to null. Okay, this is done here. Now delete at front. Just copy this function. There are minor modifications needed, so just copying this would do. Control Shift and just paste it. Delete at front. Shift F R O. Delete at front. Okay. If front is equal to null, front is equal to null, print f. Q is, yeah, again empty. Else, okay, this would be enclosed in else part, not directly. Else, else, print it again. I'm sorry, not print it again, just perform this operation. Okay, just copy this quotient, copy and paste here. Else we are equal to next of here, no, so we front now. Front equal to the next element of front. Okay, no, sorry, no, front would not be the next element of front, because the next of front finds null. I have to initialize it to the element before. Okay, let me just go back to my drawing board and just show you what happens here. Okay guys, Here I'm in my drawing board now. This is my node, first element. This is the second element. This is the third element. This is the fourth element, suppose. Here data part, the next part. Okay, the next points here, this next points here, this next points here, and this next points here. Now what I was doing is, okay, this is the front element, this is my rear element. What I was doing is I was doing front equal to next element of front. Now next of front indicates null as shown in the picture, null. So front would become null, but that's not what we want. What we want is front to be shifted here, but the next is here. So what to do now? What the approach is, what my approach is rather, I will select the last element and I will keep on jumping to the next elements until I find, this is the condition, until I find that the next element is indeed the front. When the next element is the front, means this is the element where I must stop. Now this is the element where I must stop. Okay, this is the element where I must stop, and I will save this element. Now what I will do is, now I will initialize front to this element. So front will come here, and automatically this would get deleted, because if, okay, after this I must just initialize the next to this and completely cut off the link. When this link is cut off, there is no way to find this node again, so this node is deleted now. So this is my approach. Now there can be other situations. Suppose there is only one element here. This is the rear and this is the front. Both are the same elements. Now what to do? In this case, as you see, if rear is equal to front, means the rear pointer is equal to front pointer, then just delete this and initialize both of them to null. There can be another case. If there are two elements only, this is front, and this is my rear. Okay, the nodes. Now, if there are only two elements, what I will do is I will check if the next element of rear is equal to front. In that case, I just initialize front to rear, and the same thing as the first case. Cut this link to null, and this will solve the purpose. And here I'm going to, now I'm going to show you how to perform this. Okay, let me go back to my let me go back to code blocks. Okay, let's begin with the second case. Let's suppose if front is equal to rear, if front and rear are the same elements, then what? Then just do this: initialize front to null and rear to null. Front equal to null, rear equal to null, and this would solve our purpose. Else if next element of rear is front, rear next, the next element of rear is equal to front, then do what? Then front equal to rear, and next of oops, next of rear, next of rear equal to null. Okay, else is the third condition. Else what? Else just a temporary pointer. Let's initialize here node tmp. Okay, equal to rear, PMP equal to rear. Now while next of TMP is not equal to front, keep incrementing the value of TMP. We keep incrementing the position of TMP. TMP is temporarily equal to next of TMP. So this will do the trick. After this, I am at the position of the queue just before the position of the pointer. And what to do is front equal to TMP, and next of TMP or next of point will be equals to 0. And next equal to 0 is null. Sorry, equal to null. Okay, now this goes read at front, read at rear, turn, read at end. Oops, what is this? Read at rear. What is this? Read at rear. Okay, read at front. Okay, add at end. Okay, sorry, add at beginning, add at end. Now let's just print the array. Void print, not the array, sorry, the data structure, the the dequeue. While let's implement this node star temp equal to rear, while temp not equal to null, while temp not equal to null, print the value of temp, printf %d comma data part of temp, okay, then temp is incremented, temp equal to next of temp equal to next of temp. Okay, done. So this will print the queue. Okay, let's do something. Void main, int main rather, and main. Let's add a few elements. Add beginning. Let's do this. Let's try this. Okay, let's try the add end first actually. Sorry. Okay, add end. Control shift end. Let's return a value first. Return 0. Proper indentation. Sorry. Okay. Add at end what? Add at end some value, say 4. Then print it. Let's see if we encounter some error. Print accepts no parameter argument. Okay, let's see. Okay, we added 4 and we get 4 here. Okay, now let's add another element again at end. Let's say now 1. Let's print it. Okay, 1 and 4. I have this. Add at end. I'm doing add at end means 4 is at the end. Add something behind 4. So 1 that is behind 4. 1 4. Okay, so add at end works. Now let's try add at beginning. Okay, control shift and control enter. Sorry. Add at beginning. What? Add at beginning 7. Is that 7 to beginning? Let's print it. Okay, 1 4 7. So it works. Now 1 was the rear, 4 was the front. Add at beginning. So add 7 in front of 4, and this is it. 1 4 7. That gives proper result. Now for clarification of this, let's add another element. let's say 9. Here you go, 1479, so it works as well. Fine. Now let's delete some element. Say delete it here. Control and this time I delete it. Okay. Let's show the result first. This will be initial address first 1479. Okay. Now let's delete at rear. As you can see, it's 479. So one is deleted. Now delete, so delete at rear works. Now delete at front. Let's see. Delete at rear. Okay. Let's remove it. Let's add here delete at front. Now delete an element at front. Okay. What's 147? Now as you can see, 9 is gone. Let's call this function once more. Delete at front twice. See 1 4. Also one element is gone. Another element is gone. Let's see. Okay, 1 4. Let's call again. Let's call this function again. Okay, now it's only one. Now let's see what happens if I call this function one more time. You can see no elements here. Now let's see if I receive the error message. I'll call this one more time and see. Okay, yeah, it works absolutely perfectly. Q empty. This is what we wanted. So I guess this is the first time I wrote that program, and I made no errors at all. Everything worked absolutely fine, and it gave the desired output in the required time. So as you can see here, this is I think a quite a simple program if you know the basics properly. And yeah, this is Dequeue. I have made other tutorials on priority queue, normal queue, stacks. If you haven't seen them, do see them. All of them have been coded in simple manner, nice clean code, so that you can understand better. Yeah, I have not added comments because I have been recording this video. If I add comments, it would take longer to record it. And all of the source code is going to be available in my blog. Link of the blog is going to be there in the description section. If you want the source code, do visit the blog, grab the source code and you can use it for your work. And yeah, the blog also contains other features as well, so do visit it. And if you like this video, do hit like and do subscribe for more videos like this. And as always, if you have something to say or if you think I made a mistake somewhere, do say so in the comments below. Thank you.